Welcome back. In the last video, we downloaded a pre-trained EfficientNet B0 and adjusted it to our own problem. So we downloaded some weights, we set up a model using those weights, we set all of the base layers to have the requires grad attribute as false, so we froze them. Then we adjusted the classifier head and checked out a summary of our model, and we saw that most of our model is untrainable now. So let's train the part that is. And this time we're going to do it a little bit differently to what we've done in the past. So train a single model and track results. So the whole purpose of this notebook is to explore experiment tracking with PyTorch. But before we start tracking multiple experiments, let's see what it's like to track a single experiment. And to begin, we will define a loss function and an optimizer, just like we always do. Loss function is going to be nn.crossEntropy loss, because we're dealing with multi-class classification, and the optimizer is going to be torch.optim.atom, and we will optimize our model.parameters, and we will set the learning rate to 0.001, just to keep everything consistent. Now, if you went through the little challenge I set for you in the last video, how to use TensorBoard with PyTorch, you might have found that we can use a summary writer instance. So summary writer. So you can think of this, I like to remember this as like it's just writing a summary of whatever parameters you pass it. So let's explore this a little bit more, hey? From torch.utils TensorBoard import summary writer, let's just copy this out and see what happens. So set up a summary writer. So from torch.utils.TensorBoard import summary writer. And then if we set writer is equal to summary writer, what do we get? What does this say? Well, that doesn't give us much at all, does it? How about we look up the documentation? Torch summary writer. Here we go. Beautiful. So before going further, more details on TensorBoard can be found at tensorflow.org/TensorBoard. Okay. So if we wanted to learn more about TensorBoard, we could look through here. Now this is the TensorFlow website, another deep learning framework, quite similar to PyTorch. So TensorBoard is TensorFlow's visualization toolkit. What can we do? TensorBoard provides the visualization and tooling needed for machine learning experimentation. Hey, that's us. Tracking and visualizing metrics such as loss and accuracy. Hey, we've seen loss and accuracy before. Visualizing the model graph, ops and layers. So ops is short for operations, but recall that a layer is also a collection of operations. Viewing histograms of weights, biases, or other tensions as they change over time. Okay, so during training. Projecting embeddings, displaying images, text, and audio data, profiling TensorFlow programs, and much more. Oh my goodness, there's a fair bit going on here. So if you'd like to learn more, I'll encourage you to have a look at this website. So I'm just going to link this in here. Let's get a few resources here. So to track experiments, we're going to use TensorBoard. So TensorBoard, so all of this information that we've got, this is important to note as well. And to interact with TensorBoard, we can use PyTorch's summary writer. So this is an important point, is that all of what we're doing here is not just like we've pulled this out of the air, like this is documented. We're just going to be practicing it by writing code. So let's get rid of a few of these tabs and we'll just jump straight into summary writer. What do we have here? Summary writer. Do we have the documentation? Beautiful. So I'll just link to here. So that's going straight to the documentation. Also, see here. So summary writer. Ideally, what we'd like to end up with is, well, TensorBoard's website spelled it out for us. We want to track our loss and accuracy. So we want to get some loss curves, but visualize them in TensorBoard. Yeah, just like that. Epoch, loss and accuracy. So what do we have here? Summary writer writes entries directly to event files in the log.dir to be consumed by TensorBoard. So a log directory. So what this means is that the summary writer is going to help us track some metrics to file, which TensorBoard can use. So how about we see that in practice? But the thing is that where are our metrics? So if we were to call from going modular, import engine, and then if we go engine.train, what happens here? That's how we've previously trained models, right? Well, we've got some metrics already been printed out by the train function. So let's jump into going modular, and let's have a look at engine, which is where our train function is. A little bit confusing. We've got a train step, we've got a test step, and we've got train. So previously, we've been printing out a dictionary of our model's results. And you can imagine we could keep doing that, but if we were to build like 10 models and we wanted to track all of those dictionaries, that could get a bit hard. So what we'd like to do is track these programmatically and track them to files so that they're saved. And if we wanted to export them or view them with TensorBoard, we could. So let's see how we can use the summary writer to extract these values from the results dictionary and save them to file so that they're visible with TensorBoard. To do so, I'm going to rip the function out of here, the train function, and bring that into the notebook so we can alter it. But I'm going to import.engine because our train function from engine.py uses the train step and the test step function. We have to import those as well. And we also have to import the dependencies from here. Otherwise, what we're trying to do won't work. So I'll just bring those in here and I'll go back here and I'll go back into engine.py. So all I've done is I've imported these things and I'm going to copy the entire train function into our notebook so we can alter the functionality here. So that's all I've done. So I've got engine.py and I've got the dependencies of engine.py and I've got from going modular.engine, so this function or this Python file, import train step and test step. So if I alter this function, it's got access to train step here, and it's got access to test step here. So what we want to do now is update this so it uses a summary writer. So let's add a parameter up here. We'll set this to, well, we've got device. What we might do is set this to writer. Or actually, can we pass in a writer here? What we might be able to do is just track it here. So let's go down and let's add new. That's what we want to do. So let's put in experiment tracking. We don't need a parameter just yet. We'll just set up a default writer because we've already set up a writer class up here. Let's see how we can use this in the train function. Writer, we will go writer.addScalars. Now, if you want to see this, we've got different methods here. Add scalar, if you wanted to add a single value, or add scalars, adds many scalars. That's what we want to do. Recall a scalar is just a single number. And then we've got other things like add histogram, and we've got add image. We could track our images if we really wanted to. And then we've got add images. But let's just stick with scalars because that's what our training loss and training accuracy values are. And we're going to put in the main tag parameter, which is going to be equal to loss for one of them. So this is going to be the loss scalars. Let's go tag scalar dict. And so if you want the documentation for this, see summary writer documentation for these parameters here. Tag scalar dict. We're going to pass in the values we'd like to track, train loss, as being the train loss values. So we've got that there. So this is just getting the train loss, and putting it in there. And then we can get the test loss and put it in here as well. And then we can finish off with global step. So global step is going to be tracking the values every epoch. So we're going to see what this looks like in a second. We just want to set up the writer to add some scalars to file. And then the main tag here, we want to also track the accuracy. We'll pass in a dictionary of our scalars. Now you might be able to guess what goes in here. We'll pass in the train acc, we need to do this as a string, string, and then we'll go train ACK here, and then we'll go train loss, and we'll pass in the test ACK. So that's all we've done. We've got a results dictionary, but we're also now tracking them to our writer, and our writer is the summary writer. And then we'll put the global step here is going to be equal to the current epoch, which is up here. We are looping through a range of epochs that gets passed in up here. Now, we could parameterize this. We might do this later on, actually, as I was hinting at before. Put a parameter here, so writer equals XYZ. We could put in a writer there. I'll let you do that if you'd like to try that for some extra curriculum, but we'll see that later when we run more experiments. For now, we just want to focus on tracking one. And I'll also show you there's another thing we can add, We can add graph, so we can see the computations our model goes through. So model equals model, and then we'll go input to model, which is just a demonstration of variables to go through our model, equals torch.randn. We just need a shape of random tensors to go through. It's just going to do one forward pass on our model so that we can see the computations as it goes through our model. And then finally, we're going to close the writer. So let our writer know we no longer want to track anything else. So writer.close and then end new. So a few steps there, but essentially all we've done is we've explored what TensorBoard is, a way to visually track machine learning parameters, different things. We saw that we can interact with TensorBoard using PyTorch's summary writer. And we see that the PyTorch documentation for that there. We then created a writer class with summary writer here. Now, by default, summary writer is going to track to a log directory. So the default is, here we go, logdir, save directory location. The default is it's going to save it to a file called runs, current date time, host name, which is the name of your computer. Now, we could change this to be logdir equals experiments, but we're going to see that later on. So we'll just leave it everything as default just to see what it looks like. So we've got a train function. Our original train function, we set up an engine.py, we imported it in here, and then we added some functionality here to write some information to our writer for the loss value, and write some information or some scalars to our writer for the accuracy values. And we can also track the computation graph of our model. So let's just leave that as it is. And in the next video, we're going to see what it looks like when we run the train function, our updated train function that is, and train our model. So you might want to give that a go and see what happens. What happens? Oh, we've got a runs directory. We've got one already. Look at that. Our writer has created a default runs directory for us. Okay, beautiful. So give that a shot. Use our updated train function just as we have in previous videos and see what happens. What gets added to the runs directory? We'll do it together in the next video. I'll see you there.